Find the derivatives of the following functions. In part A, we got e raised to 5x plus x to the fifth plus 5 raised to x. So e raised to something. Let's recall here when we have e raised to some function and when we find its derivative itself, because exponential function, times derivative of, from chain rule, derivative of inner function u prime. This is easy. For 5 raised to some number, in this case x, a number raised to x, its derivative is, this is also an exponential function, so itself, but we need to write down natural log of base 5 times derivative of x, which is 1. We don't have to write that. So let me go here and write down the derivative. So e to the 5x is itself times derivative of 5x, which is 5, okay, from chain rule, plus x to the fifth, that's the power rule, so 5x, 5 minus 1, 4, plus, for 5 to the x, we have here exponential function itself times natural log of base 5. Okay, it's the natural log of 5 is a decimal number. In part B, we got natural log of something. So when we have natural log of some function of x, and when we find its derivative, that's 1 over u, this argument 1 over argument times derivative of this inner function u prime. So which in this case, derivative of this function is 1 over this inside function argument x tangent x times derivative of this, which is in fact a product of two functions. So we are supposed to write derivative of this inner function, that is a product. Okay, so we need to use the product rule. So u dot v, and we know that whenever we got a product, it's u prime v plus v prime u. So derivative of x is 1 times tangent plus derivative of tangent v prime, the secant square times the first function, which is x. Okay, do not multiply these two, we may leave here. This x comes to the front, in fact. Final. In part C, we have a fraction raised to 7, so some function of x raised to n, and we know that function of x raised to n, when we find its derivative from the chain rule, that's n u n minus 1 using the power rule times derivative of u. Okay, that's from chain rule, and the whole fraction is u in this case. So its derivative is 7, the whole thing, raised to 7 minus 1, 6. So x cubed plus 2x over 5x squared minus 3 times, this is like u prime, so we need to find its derivative, which is in fact a quotient of fraction, so we need to use the quotient rule here to find the derivative of inside function. Okay, this is like u over v, and we know that the quotient rule u over v is just u prime v minus v prime u over v squared. Okay, so times this function, derivative of this fraction is 5x squared minus 3, quantity square on the bottom, on the top u prime, derivative of this top function, so x cubed means 3x squared plus 2x is 2, that's u prime times v is 5x squared minus 3, u prime v minus, okay, v prime, derivative of bottom, that's 2 times 5, 10x minus 0 is 10x, times the top, which is x cubed plus 2x. Okay, we don't have to simplify. The best we could do is multiply these two for L, distribute 10x, and combine the like terms. Okay, but this is it.